Hello everyone, in this video I will demonstrate how to create script, how to create tables using SQL command, and for that I will be using SQL Developer. So this is the ER diagram that we were discussing in my last video. So I would request viewers to please watch my last video before coming to this one, as we have discussed all the fundamentals of database design in depth in that video. So this is the ER diagram, and we are going to create these 5 tables using SQL Developer. And the focus here is going to be how to write SQL commands. So we have a rep table, we have customer tables, orders, order line, and item tables, and we have a relationship between them. As such, we know that there is one-to-many relationship between rep and customer, one-to-many between customer and orders, because one customer can place many orders. Likewise, one rep can represent many customers. So one thing you have to keep in mind when you are creating the tables is the parent table should be created first before you create the child table. So before I go ahead and create the customer table, I need to make sure that I create the rep table, because to create the child table, a parent table should be presented first. That's something to keep in mind. So likewise, I cannot create the orders table unless and until I create the customer table. Likewise, I cannot create the order line table unless and until I create both item table and orders table. So that's the order you have to keep in mind. So with that, I will go back to the SQL view here, SQL Developer, and first we are going to create a rep table, and the sample data is given here for the rep table. Okay, so if you see here, you have to look at the record and sort of come up with what kind of data type you're going to be needing. So we're going to discuss the data types as well. For example, rep number is a primary key, and it looks like a number here. This looks like a text here. Street is a text here. It's a text here. State is also text or character data or string data type. Postal code looks like a number. Commission is definitely a number. Rate is also a number. Something you have to keep in mind that you only define a field as a numeric if you are going to perform any kind of calculation on that field. For example, commissions, we might do some kind of aggregation here. Rate, we might use that as a filter or do some kind of arithmetic operations. But we would never do any kind of calculation on primary key or the postal code. So if that is the case, we would like to define that field as a text field or numeric field. I'm sorry, not the numeric field, but the text field. So so with that, we have different data types that we need to discuss here. So we have, if you have a text data type, you either choose char data type or varchar. Char is used for fixed length character data type. So for example, when we know that state is just going to be 2 character always, so we're going to use char data type for that. Varchar is sort of variable length, where like street, first name and last name, where we don't know how many characters going to be needing. So we can use variable length character data type for that. And then date is to represent the date, and then we have a decimal to represent the decimal places, with p means total number of digits you're going to have, and q means out of those total number of digits, how many digits will appear on the right side of the decimal point. So if you want to represent, let's say 999.99, so there are 5 digits, out of which 2 digits are on the right side of the decimal point. So it's going to be 5, 2. Earlier or older versions of Oracle, or even now, you can define number data type as well, like this. Basically, this is going to be the same functionality as the decimal here. You can also define int or small int. Int has this much range. Small int will have a smaller range, and it's always better to use smaller int if you don't need a bigger int type, because you can save a lot of memory here and also increase the performance of the database. Something you have to keep in mind. So with that brief information, let's get to SQL Developer here, and we're going to start writing the script here. So first thing first I'm going to do here is I'm going to create a table. So I'm going to say create table. Now when you create the table, there are certain things that you keep in mind. For example, here the table and the column name restrictions. Okay, table name cannot, or any kind of name, column name also cannot exceed more than 30 characters, must start with a letter, can contain letters, numbers, and underscores, cannot contain spaces, something to keep in mind. So with that, I'm going to say my first table is rep. I'm creating a table. So that's a command you have to issue, create table rep, and you have to open parenthesis, close parenthesis, and semicolon. That marks the end of the SQL statement. So as you know, the first, let's say the first column is a rep number. So I'm going to say my first column is going to be, let's say, rep number, and this I'm going to say this is a, I can define it as a, let's say, we can also define it, let's, for the simple thing, we're going to say small int. Okay, int. Okay, as I said, you know, since you're not going to perform any calculation on this one, you might as well define it as a character data type. Okay, so let's do it here, or let's do it, call it, you know, char data type, and let's say, you know, we're not going to have more than 2 characters. I'm going to say 2 here, then we have to put a comma, and then we have to define another one, last name and first name. So I'm going to say last name and varchar 2, because it's going to be variable length anywhere from 1 to 50 characters, or 0 to 50 characters as such. Okay, so then we have first name, again varchar 2, 50. You might be wondering how I'm getting all these highlights in the blue. Okay, so I'm using SQL Developer, and SQL Developer is gonna do that for you, so that you can sort of discriminate between uh, user supplied values and system supplied values. So whatever green you see, those are system supplied values, and whatever black you see, those are the user created values. So then we have street here. Street, I'm gonna say this is definitely varchar to 50 characters again. Then we have city, state. I'm gonna say city. Let's say varchar 2. So let's say 20 should be enough here. Then we're gonna have state. State I can use short data type, and I know it's gonna take only 2 characters. That's something you have to keep in mind. All right, and then you have postal code. Or 5, because fixed length always 5. Now when you define something as a char data type, processing is going to be faster, because then database engine knows exactly how many characters to process. While varchar, it could be a little slower, because then system needs to figure it out the variable length. So that's something you have to keep in mind. And then commission, you have commission. I'm gonna say this is decimal, and I can count the number of digits, right? So 1 2 3 4 5 6 7. So I'm gonna say I'm gonna need 7, out of which 2 will be on the right side of the decimal point. Then we have rate. More 3 comma 2, because there are 3 digits, and out of which 2 are on the right side of the decimal place. So bare minimum, you have to write this much to create a table. Let's go ahead and run the script. This is run the script. We can use a short keystroke as F5, as you've seen there. So I'm gonna press F5 here. It's going to say rep table created, and if you expand here, you should see, okay, this is system user. I want to use the Aura DB2. That's my local user, and that's a rep table we created, and it has this many fields here. Now we have to put in the constraints. Okay, the constraints gonna help us maintain the data integrity. First thing is the primary key. So there are different ways you can do the primary keys. For example, we know the rep number is a primary key, so you can just see it here, uh, constraint, let's say rep table, rep number primary key. You can call it anything you want, but this is gonna give a logical name to the constraint, which we can figure it out later on when we query the data dictionary. Something you have to keep in mind. I'm gonna say this is my primary key. Okay, so let's run the script again, and this time it's giving the error because this has the last sentence should not have the comma. So I'm going to clean this one here, and it says the name is already used by the existing object, so you cannot recreate the same table. Okay, so if you want to recreate it, you have to drop the table first. So it's always better to say drop table rep first. All right, and then recreate it. Okay, so the table dropped and recreated. You can also specify the primary key at the end of the table, which I like most, because by that you can put all the constraint in one place. So I'm going to say primary key, and since you are doing it at the end of the table, you have to specify which field is acting as a primary key. So I'm going to say rep num in parentheses, and this should work as well. Okay, so it's done there. There are other constraints you can mention, like not null. So I'm going to say here constraint, I'm going to say uh, rep underscore last name underscore not null. So I'm going to say not null. Now not null constraint cannot be put at the end of the table. Okay, it has to be mentioned right next to the field name. Okay, so this is my last name, and this is going to be my first name, not null. Okay, additional comma that needs to be removed, and I can run the script here. Okay, so this is done. So we saw two types of constraints here. So again, this naming constraint naming is not necessary. You can just delete this much and mention this is not null. That's gonna work as well. But in that case, system is gonna give very cryptic name to the constraint, and it's gonna be very difficult for you to figure it out uh, when you query the data dictionary what that name stands for. So if you give a logical name like this, it helps. Okay, so that's the first thing you have to keep in mind. So when we are writing the script here, double dash stands for comment. So we're gonna say dropping all tables. Okay, so that's my drop sequence, and here I can say creating all tables. Okay, something you have to keep in mind. So let's go ahead and create another table. So since I created the rep table, next one I can go ahead and create the customer table, and customer table has this data here. So we know that we have customer number, name is going to be exactly similar to what we did, so I don't see any changes here. So this is going to be all balance and credit limit going to be decimal. So in order to speed up the process, what I'm going to do here is I already have the script. I'm going to copy that particular line of code and paste it there. Okay, and we're going to create a foreign key constraint. Okay, just to speed it up. Okay, So here, what I'm going to do here is I can say, you can say here, uh, creating a customer table. Okay, so you can write those kind of stuff here if you want, but just to keep the thing simple, I'm just gonna create a table here called customer. And we have seen the chart 3 data type because, you know, if you see the table here, it's 3 digits, so we're going to use char 3. uh, Again, using a constraint, because if you have a customer number, it must have a customer name. Okay, likewise here, if you have a rep in your data set, it must have a last name and first name, so you cannot leave those nulls when you are inserting the values. That's all it means. So rest is very similar to what we did earlier here. You can figure it out. We have created the primary key here. Now we have to establish the relationship between, let's say, I would say there's a relationship between rep table and customer table. So rep number in customer table is acting as a foreign key to the rep number in the rep table. Okay, so the way you do that here, again, before I create the customer table, you have to make sure that the rep table is created. Otherwise, it will not enforce the referential integrity. I'm gonna say here constraint. This is customer underscore rep underscore foreign key. Okay, foreign key. I'm gonna say which is the rep number references. I need to say what table it is referencing to. Is referencing the rep table and a rep underscore number field in that table, and that should complete the code for this one. Okay, so again, we have to, if you run the script here, let's say I'm going to run this one. So we didn't get any error here, but if you rerun it, it's going to give the error because you're trying to recreate the table customer. Okay, so you cannot recreate the table customer because it's already there, it's already existing. So what we need to do is we need to drop the customer table as well, so that we should be able to run this script again and again many times. Okay, I'm going to say here drop table customer. Okay, now we can run this script many times and it's going to work flawlessly. Okay, so we are done with the 2 tables. So remember, the the drop sequence is going to be exactly opposite to the create sequence. The reason is that, you know, before you drop the parent table, you need to make sure that the child tables are dropped, or all the child tables are dropped, because you know, you cannot sort of drop the parent table because then children's going to be orphaned. That's the logic you can use here. So we have to drop the child table first before we drop the parent table. But while grading, we have to create the parent table first before we create the child table. So the next one, we have orders table. We can create the orders table. So let's go ahead and create the orders table here. And again, I have the script here. I'm going to use that one, but let's say here orders table uh, has only 3 columns: order number, order date, and customer number as a foreign key here. Okay, very simple table. So I'm going to use my written script already here. Okay, and we're going to go ahead and drop this table as well. So I'm going to say table orders. Okay, why am I using all capitals? Well, it doesn't matter, you can use different nomenclatures, that's okay. uh, I'm just keeping everything in uppercase so that it's easier to write and read as such. Maybe only constraint names are the one I'm putting in lowercase. But anyways, so here we have order number character 5, because it has 5 digits here. We're not going to perform any calculation, that's why we are using character data type, not integer or number. Order date. So order date is a date data type. So we can define this as a date. So this data type will help us store the date in the field. Okay. Character data type, and then we have order primary key, order number primary key, right? So it's order table. You can say order number here if you want to be more specific. Order number, which is a primary key. So make sure that this entire naming thing should not exceed 30 characters. Okay. So order, I'm gonna say cust number is a foreign key. Okay, which is customer number is a foreign key and is referencing to the customer in orders in the is referencing the customer number in the customers table. Okay, so let's go ahead and run this one. So it's running flawlessly right now. So all the tables are dropped and recreated. Okay, so we created 3 tables as such. The next one is can I go ahead and create order line right now, because we already created orders? The answer is no, because we need to also create item table first, because both item number and order number they are appearing here in this table as a foreign key. Okay, so we have to create the item table first, and for that let's see the data in the orders table, items table here. So we have this is going to be character data type, this is varchar data type, on hand is going to be number integer, probably small int will do there. A category going to be character data type with size of 3. Store is going to be integer, price is going to be decimal. Okay, so I have again created the script here. So in the interest of time, I will just copy this one and explain the code there. Okay, so create table item, and we have character data type, we have description as varchar 50, on hand is an integer, category type is character data type 3, storehouse we're using char data type here because probably we're not going to perform any calculation on it, which makes sense. We're not going to do any aggregation, average, max, mean on storehouse. It's just a number, so it's a char data type here. Price is a decimal with 6 digits, out of which 2 will be on the right side of the decimal places, and we have defined the primary key, and this is the parent table. It does not have any foreign key, so that's why we don't see any foreign key constraints here. Okay, so we're gonna drop the table as well. Table item, and we're gonna run the script here. So script is working fine. It's created all the 4 tables. If you right click here, refresh this one, you're gonna see all the 4 tables that you have created. Okay, so again very simple table, item table. So we have seen 3 types of constraints. We have seen primary key constraint, foreign key constraint, and not null. Other 2 types are there as well, unique constraint and check constraint. Primary key by default sort of make sure that it follows a unique constraint. So it has a combination of unique constraint and not null constraint built into it. So a primary key cannot be null, a primary key must be unique. Okay, so when you define something as a primary key, by default it is unique and not null. Foreign key could be null. Okay, foreign key could be null because some record may not have any assigned foreign keys yet. Okay, so that's perfectly allowed, not the primary key. So moving on, let's see here. We have, if you see the ER diagram here, so we created the item table. The last one is order line, and order line is gonna look like this. It has 4 columns, out of which order number and item number are the foreign keys, and this is the integer and this is the decimal. So again, in the interest of time, I will just copy this thing here and explain the code from there. Okay, so here I can go ahead and put this one, order line. Okay, so order line has order number, and I need to make sure that this is a foreign key, right? so it should follow the same notation as the order number in the order table, and that's going to be with any foreign key that you do. Okay, so whenever you have a foreign key, for example, let's start here, rep table, right? So rep number in the customer table has a char of with the allowable width of 2, and that's the same thing here. Okay, the parent table. So you cannot have a different data types. Okay, otherwise it will not create the referential integrity. So foreign key must be exactly same as the primary key that you have to keep in mind. So order number is defined as character 5, because if you go to the orders table, that's defined as character 5. Okay, so we're gonna match that. So we create the item number character 4, because here we defined item number with char 4 data type. Order number is going to be decimal. Order number ordered, right? So I don't know why it's decimal, but it could be looks like in small end. So we can change that one here. We can say order number is going to be a small end. Okay, quoted price is going to be decimal. So we have a composite primary key. Okay, so that's something I can explain here. So we have a primary key, and then you have to just mention those two fields here. So for example, this far we have seen that here, instead of mentioning one field, I'm going to say order number comma item number. All right, that's how you indicate a composite key. It's a composite primary key, so it consists of two fields. Okay, order number and item number, and the combination of these two fields should create a unique identity for every record in the order line table. Something you have to keep in mind. Out of which we have created the foreign key. Order number is a foreign key which is referencing to the order number in the orders table, and item number here is a foreign key which is referencing to the item number in the items table. Okay, so something you have to keep in mind. And we're going to drop this table as well in the reverse order. So we're going to say here drop table. Let's say that was order line, right? Say drop table order line. So let me just copy this one to avoid any errors there. Semicolon, and we're going to run the script here. So first time is going to give me the error for order line because it was not there. But if you rerun the script, no errors at all. Okay, something you have to keep in mind. Okay, so if you refresh this one, you get all the 5 tables here. Okay, one thing you have to keep in mind that it's always better to write couple of lines of code and run it, and then add the third line of code and run it again, and add the fourth line of code and run it again. By that, if there are any errors, you can catch it right then and there. Okay, so we have created the 5 tables, we have established the relationship between them, and we have looked at some constraints as well. Okay, especially 3 types of constraint: primary key, foreign key, which are mostly the table level constraints, and we have seen the not null constraint, which is more sort of a field level constraint. Something you have to keep in mind. So we have created the tables here. Now the next thing we have to do is we have to start loading the information. Again, double dash means it's a comment, so I'm going to say inserting records into tables. Okay, you can also use if you want to comment out the entire block of code, what you can do is /* and you can say */ that means this much line of code is commented out, will not be sort of uh, uh, will not be executed by the command. Okay, so item table is going to stop there, it's not going to do the item line. Okay, so we're just going to uncomment this one. Okay, and we're going to start inserting the record. So if you want to insert the record, let's say start with the rep table. Okay, so rep table is here, so let's go ahead and insert the first one here. Okay, so what we're gonna do here, we are going to do insert into rep values, and we're gonna put all those values in there. I know that the rep number is a character, so it's gonna be in single quote. Anything that is character or data type or text data type has to be enclosed in a single quote. That you have to keep in mind. So likewise, last name is gonna be single quote compose. This is like a case sensitive, so make sure you type it right. Okay, so compose is there, and the first name is Raphael. There's also a character data type, and then we have street 724 Venus Drive. Okay, single quote, and then we have city as character data type again, Grove, and then we have a state character data type CA. So it's a character or varchar 2 data type. You have to enclose that in single quotes. Okay. Postal code is also a character data type 90092. Okay. And then you have commission, which is decimal. So I'm going to say 23,457.50, and rate is 0.06. So I can just run this much command here, because, or I can run the entire script and see that one row is inserted in this one. Okay, so likewise you can go ahead and insert rest of the record. Other thing you have to keep in mind here is sometimes you don't have the values. Sometimes you just want to leave the values null. Now I cannot leave the compose and Raphael and 15 null, because we enforce a constraint here, right? This is the primary key, cannot be null. This is also first name and last name cannot be null, but rest of the field could be null, which means that all I can do is, instead of this address here, I can just say that I'm not supplying any values here, not supplying any values here. Okay, not here, not here, not here. Okay, not here. Okay, and this should work, I guess. If not, we have to specify is I guess we have to specify a single code here that indicates null value. So single code here. Okay, so that has been run here. That's something you have to keep in mind. Okay, if you want to insert the null values, there are other ways to insert the records, but I will restrict my demonstration to just this one. And in the interest of time, I'm gonna copy all the values here. Okay, and put it there. And since this is a script, I can run everything from the scratch, and it's going to create those records for me, all the 4 records. So next thing we have to do is we have to sort of insert data into the customer table, right? So again, we can do similar thing, exactly similar. So this is into, say, rep table, and likewise I can do values into table, see values. Okay, and in the interest of time, I can just copy this one. And one thing I would like to point it out here, which I'm going to discuss here. So you can type all these things in, but one thing you have to keep in mind here is, because these are all the text field, all text field, and these are the decimal, and so the 31 is the 30th. This number 30 is the my rep number here. So just to make sure, this is decimal and this is also decimal. So do we have those things there? So we have decimal and decimal, credit limit balance. Okay, they both are decimal, so we are good there. And other thing you have to keep in mind is if you let me show you the data here. This cleans, KLINES, KLI cleans, that's apostrophe is S. Okay, so or Johnson's department store, this apostrophe is S. So 386 Johnson. So that's how you're gonna do it. If you want to put apostrophe S, is gonna be double single quotes. So you have to do the single quotes 2 times, not a double quote. You cannot put a double quote like this. Not gonna work. Single quote and single quote. That's gonna put apostrophe S into the database field. Something you have to keep in mind. Okay. So if I run this one, so we inserted, we didn't get any errors, so everything is working fine. Now let's go ahead and insert the record in the third table, with the third table being orders table, right? So if we did the customer, we're going to do the orders table. So we're going to say here, insert data into orders table. And if you look at the orders table here, it has an order number, it has a date, data type. Okay, that's a different way of inserting the values here that we're going to see here. And then customer number is the foreign key here. So let's say I can do here, let's say insert values into what is the name, orders. You can also see here orders is the table, and you can see the field there as well. Orders, insert into orders values, and we just have so we have first one as 51608. Okay, then we have date, so we have a date of 10/12/2015. So we have to say to underscore date, where to put the date there is like 10/12/2015. And then we have to specify the format. So it's going to be MMDDYYYY format. So that's the format dimension there. Okay, so here I need to have a comma here to underscore date, and then we have customer 126, which is a character data type. Remember, 126 is a character, and I have to enclose that in single quotes. Okay, so I can just run this one here. So this is working. Likewise, you can go ahead and insert all the data there, but I'm in the interest of time, I'm just going to copy the data here and put it all here. Okay, and run the script here. So I'm not getting any errors. All the scripts, the complete script has run flawlessly here. So we are done with that one. The last orders tables, now we have items table, right? So I'm gonna say insert values in the items table into item table. And if you go back to item table here, this is character data type, description character on hand is int data type, right? This is character, this is character data type, and this is decimal. Okay, so nothing new. So I'm just going to copy the data from my script here and save some time here. So again, if you see the item table, on hand is we defined as a small int there. This is a character and this is a decimal. So you go here, on hand is an int. Okay, so all that I'm inserting here is a decimal, but it should not make any difference. So even if you leave it that like that, it should be the same thing. Okay, so let's run it and see whether that creates any trouble. So that did not create any trouble. Okay, but when you're defining something as an int, you should stick to the standard and just say, these are all integer values. Okay, something you have to keep in mind. Okay. Awesome. So we have done that one. Let's run the script again. No errors at all. So we have done with the item values. And the last thing is the order line, right? This one. So again, this both are character data type, number ordered, integer, and this is quoted price as decimal. Nothing new. So we're just gonna copy the script here. Say here, I'm gonna say here. Okay. Again, order line table, I just want to cross check here. We have seen a small int there, number order, right? So number order, I'm just gonna say, you can just remove this one, doesn't matter. Okay, but officially you should remove all those things there. Commit is gonna physically go ahead and write all this data into the database engine or database file as such. Unless you commit, those are not physically written to the memory, but by default when you close the SQL developer, commit happens and it's going to be all written. But it's always good to explicitly commit the statements so that they are all written to the database file here. So everything is done here. We have created a table, we have followed a particular sequence, right? And then we have inserted the records in the table. Okay, now let's say how you can select the records from the table. So what we can do here is, let's say first I want to describe what's there in a table. For example, I want to know the field and the data type. So you write a command called describe. Let's say I repeat rep here, and I can just highlight this one and just run this one as a thing. So it's going to give me detail about the ref number, not null. So by default tells you whether it is null or not null, and gives the data type as well. Okay, something you have to keep in mind. So you can go ahead and define any table, describe any table you want. Okay, so describe customer and highlight this one, run this one. So it's going to be describing that table as well. Okay. Now let's say you want to select the data, right? You inserted the data. I want to select. Let's select star from rep table. That means give me all the records from the rep table. So I'm just executing that command. Is gonna give me the data here. So I can go ahead and say select star from customer. Okay. So I can run this one as well, highlight this one. So it's going to give me the data for the customer. Okay. I guess you have to set the buffer size so that you don't cut you off, but that's not the focus here, so I'm not going to worry about that. So anything else am I missing? So let's see. Okay, so now we have to save the script. Okay, and do other things as well. We're gonna discuss a lot of other things, delete command, update command in other videos as well, so not gonna worry about them here. Okay, and so we're gonna talk about user constraints and other things. So user constraints is if you see that so let's say you want to select particular field from the rep table. I just want to order from the customer table, or let's say I want to select select only let's say item number, and description from item table. So you can do that. You can just select particular fields. Okay. So I did have item number misspelled here. Okay, it tells you that you misspelled that one. So it just select those two columns. And there's a data dictionary maintained by the Oracle. Behind the scene, Oracle create a lot of system level tables which you can query for your benefit. So one of the table is, I'm going to say user underscores constraint. So it tells you all the constraints that have been created by the you as a user. Okay, I'm sorry, I just should not have done that. But anyway, it executed the entire thing. But the last one is a user underscore constraint table. It's a system level table and tells you the owner, the constraint name, the constraint time, the table name. Okay, so you can let's say you want to select. So I can select particular columns from here. So I'm going to say select owner constraint underscore name constraint underscore type and table underscore name. Let's say table underscore name from the table. So that's going to be our table. User, I'm going to sorry, user underscore. Okay. So basically this telling me that I'm only selecting few columns from the system label table called user underscore constraint, and that's going to show me all the constraints that I have created so far, right? So basically this tells me oh, so this is going to do it for every table. Okay, another better view you might get often not running it as this as a script, but running this as a command. So if you just run it as a command, so it's going to be a better view here. But you know, table name, there's a lot of tables, we're not worried about that table. But if you look at the orders table, let's say you just want to do it for the orders table. Okay, instead of showing all of them, we can say we can put a where clause where, let's say, table underscore name equals orders. Okay, so if you just execute this one as a statement, it tells you that you have two constraints, foreign key and primary key. See the name we gave, otherwise system would have given its cryptic name, something you have to keep in mind. So this tells you, you know, all the constraints that you have created for the table orders. Likewise, you can do it for any other table. Let's say I want to save this as a script, and while saving this as a script, I want to comment out this one because these are not part of the script as such. I wanted to have it for my reference. Okay, so we can have this one, and I want to save it. So I'm going to save it. Let's say I created a folder on the C drive here, and let's say my script, and already have a tile distributor. Let's say, you know, I'm just going to call it tile underscore new .sql. So that's going to save it as a script. Okay, so let's say, so I created a script, I saved everything. Now the beauty about the script is, you know, you don't need to worry about copy and pasting. You can, once you have the script, you can say start here, start. We know that we saved it as C drive backslash my scripts backslash cal underscore new and .sql. Okay, and press F5. It's just gonna go ahead and boom, run all the commands in that script, you know, so don't need to worry about it. Okay, so instead of start, you can also say here ampersand, that symbol, and again you can just run it as a script, and it's gonna go ahead and create all the tables and run all the commands in that script file. So that's a little bit about how to create tables, how to create script. We also have seen different types of data types. We have also seen how to comment out a single line of command and how to comment a block of commands as well. uh, and a lot of other things. So with that, I would like to conclude my video here. Thank you very much for listening.